Hey guys, welcome back to another video. In this video, I'll be taking Legendre and Cauchy methods. So let's start with Cauchy method. So this is Cauchy differential equation. So in this, we have this is the the system. This is the form in which Cauchy sums are there. For example, they will give a question where we have to find out first whether it is a Legendre sum or it is a Cauchy sum. So when it is x raised to n, when the first term over here is x, then it is Cauchy. And for example, when we have ax plus b raised to n, then this method will be Legendre method. So then let's look into Cauchy method first. We'll keep it as a difference so that we'll understand it better. So x raised to n, d raised to n, y, dx, n. So now this is the form. And for example, if the n is 3, then it will be x raised to 3, d cube y upon dx cube plus. Now x raised to 3 minus 1 is 2. Now x raised to 2, d 2y upon dx square. So now this will be the method, it goes so on. Then y is equal to f of x. So when we understand it is a Cauchy sum, then after writing the sum, we have to put x is equal to e raised to z. Now wherever we have x in the sum, we have to put it e raised to z, and then z is equal to log x. The important terms that in Cauchy we have to remember. In Cauchy sums, we have to put x is equal to e raised to z and z is equal to log x as soon as the sum starts. Then now we simplify it. While simplifying, what we do is, when we have, as I said, if the x cube is there, x cube d cube y upon dx cube, then the way we simplify is, we first write d. D is for a single term. For example, if there is only x with power 1, then we write dy. When we have x with power 2, then we write d into d minus 1y. When we have x cube with the power of 3, then we write d into d minus 1 into d minus 2. The same way, if we have x raised to 4, then we will write d into d minus 1 into d minus 2 into d minus 3y. So this is Cauchy method. Now we will see Legendre differential equation. As I said, to recognize whether the sum is a Cauchy or Legendre, it depends on this line. So if our equation has something like ax plus b raised to n, if we have some term like this, then it is Legendre method. And as soon as we get to know when a sum is Legendre, we have to put ax plus b is equal to e raised to z. And then z is equal. So in Legendre method, as soon as we get to know about whether it is a Legendre or it is a Cauchy, we get to know by seeing this term. So we have to put ax plus b is equal to e raised to z, and z is equal to log ax plus b. So then the simplification of this Legendre method will be, if ax plus b whole raised to 3, if it is a cube, then we have to write a cube into d minus 1 into d minus 2. It is very similar to Cauchy method. Just the thing is that when it is cube, then we have to write over here, we have to multiply with a cube with the same term as Cauchy. Then when it is a square, we have to multiply it by a square with the same term. Then when there is when the power is 1, then we have to multiply it with single a. This a will be this ax. So whichever number will be over here, we have to multiply this over here. So let's start. Now I'll take some examples to make it more clear, the Legendre and Cauchy methods. So here we have taken one sum. So first we have to identify this, whether it is a Legendre or a Cauchy. So let's see. It is x raised to n, and over here also we have something like x raised to n, that is x raised to 2. So this is Cauchy method, because in Legendre method it will be ax plus b raised to n. So we understood that this is Cauchy method. So let us keep this over here for reference, and we'll start with this. first we understood that it is a Cauchy. So we'll write it Cauchy differential equation. Okay, then we know it is a Cauchy method. So what we have to do first is, it is written, put x is equal to e raised to z and z is equal to log x. So let's do that. Put x is equal to e raised to z and z is equal to log x. This two thing we have to put. Then first we'll see that over here they have told how to simplify. This you all understood. So let's try with this. First we'll take x square d square y by dx square. So our answer for this will be d into d minus 1 y, as it is two terms, x square. Then for this it will be 4x into, this is into 4x into dy by dx. So answer to this will be this 4 into, it will come outside. Okay, so when we have a single power, then we write just dy. So then now we can put this in this equation. That is, in place of this we have to write this. That will be d into d minus 1 y minus 4 dy plus 6y is equal to x raised to 5. Now this will be, if we simplify this, it will become d square y minus dy minus 4 dy plus 6y is equal to x raised to 5. Now if you remember here, what I've said is, in the place of x we have to put e raised to z, and in the place of z we have to put log x. So let's do that. Over here we have x raised to something, so in the place of x we have to put e raised to z. D square y minus dy minus 4 dy plus 6y is equal to, now in this place we put e raised to z. Now it is raised to 5, so e raised to 5z is what we write over here. Okay, now minus 1 plus 4, minus 1 minus 4 will be minus 5. So it will be d square y minus 5 dy plus 6y is equal to e raised to 5z. So now we can take y as 1. We'll take y outside. D square minus 5d plus 6 is equal to e raised to 5z. Now we can take AE. Auxiliary equation is phi of d is equal to 0. So this means that this phi of d we have to put it as 0, equal to 0. So then we write d square minus 5d plus 6 is equal to 0. Now we have to take the roots. Now you can take the roots by using calculus. So the roots will be d is equal to 3, 2. There are two roots because it is a square. So 3 and 2 are the two roots. Now we can write yc. Yc is equal to c1. Now we have kept all this in z term. So c1 e raised to 3z plus c2 e raised to 2z, because we have put x is equal to z and this everything is in z form. So therefore we are writing e raised to 3z and 2z. Now we'll remove yp. So for now yp is equal to 1 upon phi of d into f of x. Now our phi of d is this part. This is a phi of d. So we can write that 1 upon d square minus 5d plus 6 into f of x. F of x is this one, e raised to 5z. 5z. So if you remember the case 1, in case 1, whenever we have something like e raised to 2x, 3x, 5x, in that case we used to put d is equal to 5 or d is equal to 2, like that. So then over here just the x term is replaced by z, so we can apply the same case. So over here we are putting d is equal to 5, then it becomes 1 upon 25, because 5 5s are 25, minus 5 5s are again 25, plus 6 into e raised to 5z. So plus 25 minus 25 gets cut, then what remains is 1 upon 6 into e raised to 5z. Now this is our yp, the equation 2, and this is our yc, this one, the equation 1. So now we have to find out y. Now what for final answer we have yc where we have z term. Now we have to convert it into x. It is 3z. So then wherever there is z, it is written, put z is equal to log x. So in the place of this z we'll put log x, and similarly in yp, in this place of z we'll put log x. So let's write. We are writing y is equal to c1, we had e raised to, the roots were e raised to 3z plus c1 e raised to 2z. Now in the place of, this is yc, in the place of z we'll be putting log x. So we'll write it is c1 e raised to 3 log x plus c2 e raised to 2 log x. Okay, so this is our yc, then our yp is 1 upon 6 into e raised to 5z. So in the place of z again we'll be putting log x, which will be 1 upon 6 into e raised to 5 log x. So now we have yc and yp in x form. So we can write it, y will be y is yc plus yp. So y is, we'll write this line, c1 e raised to 3 log x plus c2 e raised to 2 log x plus 1 upon 6 into e raised to 5 log x. So this is the final answer. Thank you for watching the video. If you like the video, please like, share and subscribe to my channel for more upcoming videos. In the upcoming videos I'll be taking some more example on Legendre and Cauchy method. So stay tuned. Thank you.